Hello students, today we are going to discuss kinematic equations, and what I would like to do is I want to start off with our primitives, and I guess I should say the primitive, and then I want to say, like, I guess corollaries to a primitive, and we've discussed this before, and the primitives are the primitive, all right, it's going to be the meter. All right. The meter means to measure. Okay. So that's pretty much what the meter means. And so I'll just do this. So if we can measure some length with a meter stick, then we are able to measure a volume. So if we can measure, and I'm saying length, but just to be a little bit more formal, let me call it distance. Okay, and distance can be labeled in terms of length, width, and height. Okay. So that's cool. When we think about it in terms of that, we could come up with something known as volume, and we even talked about that a little bit. So we can have volume of a cube, where we have some height here, we have some length, and we have some width. So we know that the volume is just equal to the length times the width times the height. And this is going to be cubic. So if we were talking in terms of meters, this would be cubic meters. So that means meters to the third power. Okay? Now if we have volume, and then if you want to throw something like density into this mix, density of a substance, then now you'll end up with mass. So mass is going to be equal to, density times volume. So density is going to be a property of a material, and volume is as well a parameter of a material. So if you have this parameter which is manipulated or formally specified in terms of the meter, then we can really define the mass of an object exceptionally well. So know that much of what we do in physics is measure. It's our ability to measure and then verify that measurement. When you do an experiment, you're seeking to measure something, okay? And even to form hypotheses with it, but that doesn't have to be the end. So now that we have that, we have another thing that we could say. Let me go back. So time would be the next one, and I could just say distance. Let me just do this. Distance is equal to speed, the product of speed and time. See that? So if you look at this, it's like time is a coefficient to relate distance to speed. So is it really real? You know, I mean, we can define it, all kind of things, all kind of ways you can go with that. But we're going to go with it in this particular case. So we'll call time is just equal to distance over speed. And that's kind of it when it comes to those primitives. So yeah, this is great, this is important, but what is the point? Well, in the next video, I seek to elaborate on these ideas, okay? On the idea of the meter, which could be measured in some x Y, or Z, or S directions. And I should say directions are, yeah, directions. And also the unit of mass, as well as time. So all of these are units that can be measured as far as primitives go.